Hello students and welcome to second term mathematics. I want to believe that you had a great time during your first term and that you enjoyed your break as well. Now it is time for second term mathematics. And in the JSS1 curriculum, the very first topic we're going to be looking at is approximation. Now, this is something that you're quite familiar with. However, we'll be looking at it yet again, at this time taking it to another level and trying to do some mathematical functions, mathematical works with what we already know about approximation. But of course, here we don't assume. So what we're going to do is we'll take a little review into what approximation is, and then we go on to apply it to different basic operations and our everyday activities that involves approximation. So please ensure that you're subscribed to the channel. That is one way of encouraging us to continue to make more helpful videos like this. And don't forget that you also need to help your friends just as much. And how you can help them is by sharing this video so that they too can have access to our channel where they get educational videos like this and grow day by day in their academic life. Thank you so much for subscribing and thank you for sharing. Don't forget also that if you do have any question at all, whether it's during the video or during your own study time, feel free to ask us that question. You know that we here at Oyalearn, we are intentional about helping you grow academically. So we welcome all kinds of questions. All you need to do is put them in the comment section and we'll attend to all of your comments. Thank you so much. So the first topic in second term of JSS1 mathematics, like I mentioned, is approximation. And as part of the video, we're going to be looking at the meaning of approximation. This is where we are looking back into what approximation is. Remember, I said that it's something that we are quite familiar with. So we need to revisit that, tell the meaning of approximation, and then we'll remind ourselves of the approximation process. That is, if you're asked to approximate a certain value, what are the steps that you need to take in order to ensure that you do it correctly? After that, we then look at approximation of numbers to specific degree of accuracy. Now, at this point, I will be looking at some of those aspects, those kind of questions that involves approximation. You could be asked to approximate based on the following degree of accuracy, whether it is by place value, where they say approximate a certain value to the nearest whole number, to the nearest tenth, to the nearest hundreds, to the nearest thousands, to the nearest tenth, hundredths, and so on like that. That's by place value. You could also be asked to approximate by number of decimal places, often shortened to DPs. Okay, so we'll learn how to approximate to 1 decimal place, to 2 decimal place, to 3 decimal place, and so on. After that, we also look at approximation by significant figures. So you need to know what significant figures are and how we approximate by significant figures. And we'll do that at this point. Then we graduate into approximation involving basic operations, where you're asked to compare where you approximate the figures before doing the basic operations, or sometimes do the basic operations then approximate your answers. We look at those two, and then we end the class by looking at everyday activities involving approximation. We do believe that by the end of this video, you should be able to solve many questions involving these itemized objectives. So get ready and let us do some approximation mathematics. Let us now look at the meaning of approximation. Okay, there are quite a number of mathematical tasks that you will be given that involves you approximating. But you always want to ask that question, what does approximation really means? So let's look at the definition of approximation. And to understand this, let me tell you a little story. Now, this is an absolute real story. I have a group of students that I train for in their mathematics, and recently we're working on construction of shapes. Okay, now when we want to do construction, there are a few instruments that is required that every student needs to get. So there's this particular student that hasn't gotten their own instrument. I gave a list out, and this particular student hasn't got theirs. So when I asked, the parents told me that I should make the price list for those instruments, that they don't know how much it will cost, and they don't live close to a bookshop where they could get those instruments. So I offered instead to buy the instruments, and then they reimbursed me, but they didn't want me to do that. So instead, they just asked me to give them a value that is close enough to the value or to the price of those instruments. Now, here's the thing. I didn't remember the exact amount I bought those instruments when I did buy them last. So all I had to do was to give a number that is a little bit bumped up, okay? So that when I get to the store, right, I will have enough money to buy those instruments. I will not have less. You see that kind of scenario, right? I had to bump up the price that I have in my head. I don't know the exact price, but I know it is between a certain digit. So I just bumped it up a little bit so that once I get to where I need to buy this instrument from, I will know that I have enough cash on me to buy that particular instrument. And it did work. You see, this is some of the things that we do in our day-to-day life where we can't work with the exact figure for something, and we just have to guess a number or estimate a value that is close enough to the right number. It is not exact, it's just close enough. And one thing about those kind of values is that sometimes they are quite easy to work with. So you see that number that you have to guess or that you have to estimate that is not exact but close enough to the exact value and can be used for a specific purpose, that particular value is what we call the estimate value or approximate value. So if you're asked to define approximation, this is what you should say. Approximation is an estimate or inexact value that is close enough to the exact value for a specific purpose. So whenever you're doing any mathematical operation and you have to estimate or guess a number that is not exactly what you need, but is close enough to what you need and can be used for a specific purpose, what you are doing in that case is approximation. So if I'm going to put it in simpler terms, I would say it is simply guessing a number that is close enough to the exact value and easy to work with. Let's note that down. It involves guessing a number close enough to the exact value, but easy to work with. Okay, so for example, if you're asked to do something like, say, 912 multiplied by 8. Now, when you look at those two numbers, it's quite difficult to multiply them directly. So what do? You approximate them, okay, such that you get numbers that are closer to it. So like, for example, 912 is closer to 900, so I can drop that down to 900, and 8 is closer to 10. I can do 900 multiplied by 10, and that will give me what? About 9,000, which is close enough to what you will get when you multiply 912 and 8. It's close enough, okay? It is not exact, but it's close enough, and it makes your calculation a lot more easier than it would have been if you were to use the exact numbers. So that's basically what approximation is, and trust me, we use it in our day-to-day life. You'll soon begin to see some of those examples where we apply approximation, okay? So now that we know the meaning of approximation, let us look at the different steps you need to take in order to approximate a value to specific accuracies. When it comes to approximating values, it is very important that we understand what degree of accuracy is. Now, one of the common degree of accuracy is the place value system. And if you recall, during our first term, we did talk about what place values are. And then we broke them down into series of digits, so we worked in groups of threes. And the lowest ones were the group of ones, where we have the unit, the tens, and the hundreds place value. And then above that, we have the next set of threes, where you have the thousand, the tens of thousands, and then the hundreds of thousands. And then moving to the next, we had the millions, where we have units of millions, tens of millions, hundreds of millions. And it continues like that into groups of billions, trillions, quadrillions, quintillions, and so on like that. Okay? So that is one of those parts where you have to bear in mind whenever you're trying to approximate. Remember that you always work with place values. So understand your place values, and if you do have any question concerning place values, you can drop it in the comment section. Another thing you can do in addition to that is to check out our video from first term JSS1 where we talked about place values. Trust me, it's an impactful video. When you watch that video, you will totally understand what place values are. Okay, another thing you need to know when it comes to approximating values is to know that there are other degrees of accuracy such as decimal places and significant figures. Okay, all of these come together to help you approximate a value correctly to the specified degree of accuracy. Okay, now there are two steps I can explain to you that will help you understand everything that has to do with approximating values. This is sort of a compressed version of what we did in JSS1. So this time it compresses all the steps into just two simple steps. Now the first thing you have to do is to keep the required number of digits in the questions. So if the question is asking you to do it by place value, identify the place value you are working to, and those will be the number of digits you have to work with. Okay, from that place value and beyond it, you have the digits you can keep, and then after that place value downwards, you have the other digits that are negligible. Okay, so always identify the number of digits you're asked to keep by the question, and then what you do to that digit and the next ones. Okay, that's what you see in step 2. Step 2 then says before you round off the remaining digits, okay, you have to look at the next one after that digit you have to keep. Okay, so the next digit will let you know what to do next. So, and it says if the next digit is 5 or more, that is 5, 6, 7, 8, and 9. If it is any of those I've mentioned, I come again. If it is 5, 6, 7, 8, or 9, you're going to add 1 to the last digit, and then the remaining ones can then be rounded to 0. Okay, but if it is less than this particular digit, that is if it is otherwise, from what we have here, the statement here says otherwise, leave it as it is. Okay, which means that if the next digit is 4, if it is 3, 2, 1, or 0, then you leave the digits as they are and round off the remaining unwanted ones into zeros. Don't forget, first, keep the number of digits that the question asks that you keep. Then you look at the next digit to the last one, and then you see that if it is 5, 6, 7, 8, or 9, you have to add 1 to the last digit of the number of digits you are asked to keep. And then if it is 4, 3, 2, 1, 0, you leave those digits as they are and round off the unwanted ones into zeros. Okay, so that's basically the 2 steps you need to remember when it comes to approximating numbers or rounding off numbers. Okay, so let's look at a few examples working with these different degree of accuracies, and then we see a live practice of approximation process. Let us apply the approximation process to solving this problem. So we're asked to approximate 1.867 to the nearest whole number, the nearest tenth, 2 decimal places, and 2 significant figures. Now, so that we understand this entire process, I'm going to stick to these same degrees of accuracy for a number of questions, okay? So we're just going to keep doing this same thing but to different numbers. So let me partition the board now so that we have 4 spaces to work with. Now we have 4 spaces on the board, and then we'll use this for whole number, we'll use this for nearest tenth, this for two decimal places and this for two significant figures. Okay, please do note that when you have this symbol in mathematics, DP, it means decimal places. And then SF in mathematics stands for significant figures. Okay, so let's start with the very first one. So we're going to approximate 1.87 to the nearest whole number. Now what that means is we're going to approximate it to the nearest unit. Okay, so when we have this 1.867 to nearest whole number, what that means is that we're going to keep the number of digits we are asked to work with. So how many digits are we supposed to work with? As this is a whole number, any digits that come before the decimal point are whole numbers. So we can see that we only have one digit there, so that would mean we are keeping 1. Okay, so since we are going to keep 1, what does that mean? We are now going to look at whatever comes next to 1. Okay, now what comes next to 1? We have the point and then we have 8, 6, 7. Now you see what we have here. We're going to consider just this alone. Only this is what we're going to consider. Okay, and remember that if the next digit is 5, 6, 7, 8 or 9, it means that we're going to what? Add 1 to this, plus 1. So 1 plus 1 will give us what? 2. And then every other digit that are unwanted will be rounded down to zeros. So we have 0, 0, 0. So our answer is basically 2 to nearest whole number. Okay? So we have an approximate value of 2, which is this, to the nearest whole number. Now let's go to the second part. Now we want to approximate it to the nearest tenth. Okay, so we have 1.867 to nearest tenth. This is another case of place value, and the place value with the tenth place value rather belongs here. This is the tenth. Okay, so it means we have 1.8. We keep that value. Now every other thing that comes next is what we have to consider. So we have 6 and 7, and we're going to consider the next one after the number of digits we have to keep, and that is 6, right? So because it falls within the bracket of 5, 6, 7, 8 or 9, it means that we are going to do what? Add 1. So it means 1.8 plus 0.1, and this would give us what? 1.9. So our answer is approximately 1.9 to nearest tenth. Okay, so it means this gives us 1.900, which is basically 1.9. Now we're going to look at two decimal places. So 1.867 to 2 dps. Okay, so for 2 decimal places, it means after the decimal points we count 2 digits. So 1 point, now 8 and 6. These are the 2 digits. Okay, the next one that comes will be placed under consideration to see what happens before we round down the rest. So, and since it falls within the brackets of what? 5, 6, 7, 8 or 9, once again we're going to add 1. So plus 0.0. Now we add 1 to this particular one, and when we do that we get 1.87. And whatever comes next is rounded to 0. So this is approximately 1.87 to 2 dps. Okay, now let's do significant figures. So 1.867 to 2 SF. What does this mean? It means from the first non-zero you count 2 digits after the first non-zero. So this is the first non-zero, so that counts as 1. The next digit becomes the second significant figure, whether it is 0 or not. We always start from the first non-zero as the first significant figure. Every other digit then counts, whether they are zeros or non-zeros. So this is 1 and then this is 2. So we are keeping 1.8. Okay, so we are going to consider the next one that comes, which is the 6. So it means we are adding 1 to this, so plus 0.1. And this gives us what? 1.9. All of this will then be rounded to zeros. Okay, which means we have 1.900, which is basically 1.9 to 2 significant figures. And this is just how we approximate numbers to these stated degrees of accuracy. Let's look at more examples, still working with the same degree of accuracy. Here is another example for you. This asks that we approximate 6.0748 to the nearest whole number, to the nearest tenth, to 2 decimal places, and to 2 significant figures. So like we did last time, let's do the same thing. So now we're doing 6.0748 to nearest whole number. Okay, so when we look at this, the digits before the decimal place indicates the whole numbers. Okay, so we only have 1 digit, so it means we're keeping 6. Definitely, we have to keep 6, right? Okay, now the next step says that we look at the next digit after 6. So I won't be doing what I was doing last time, where we begin to identify all the digits, but here we're going to look at just the next one, and the next one is what? 0. Okay, now what happens when the next digit is 0? Remember, it's not just for 0, for 1, for 2, for 3, and 4. Those numbers are 4 digits. 0, 1, 2, 3, 4 fall amongst those that means we do not do anything to the number of digits we have to keep. Okay, remember, if it is 5, 6, 7, 8, or 9, we have to add 1 to the number of digits we are asked to keep. Okay, so but since this is amongst the group of digits that says that we keep the remaining digits as they are and then round down the unwanted ones to 0, it means we keep 6 just as it is, and then we round down every other thing to 0. So the unwanted digits become what? Zeros. So which means our answer is just 6. And it's as simple as that. Now the next one says to do the same thing but now to the nearest tenth. Okay, so now we have 6.0748 to the nearest tenth, to nearest tenth. Okay, now this says that we have to keep a certain digit until we get to the 10th place value, which is what we have here. So we have 6.0. So all of these are not what we want. This is the 10th place value. This is 100, this is 1,000, this is tens of thousands. Okay, so now we are going to keep up to this 0. Now that we have this, we now look at the next digit. The next digit is a 7. Okay, and 7 falls amongst the 5, 6, 7, 8, or 9, which implies that we have to add 1 to what we are asked to keep. So we add 1 here. So let's add. We have 6.1 now. So our answer is just 6.1. Now let's do the same thing to 2 decimal places. So now we have 6.0748. Okay, so to 2 decimal places. So 2 digits after the decimal points is what we have to keep. So we have 6.07. Okay, so now that we have this, we now look at the next digit after that, and that next digit is a 4. And 4 falls amongst those that say we do not do anything what we already have, but instead round the remaining down to 0. So it means what we're going to be having is all of this becomes zeros. So now our final answer is 6.07. And you can see that's 2 decimal places. Now the final one, we have 6.0748. And we have to do it to 2 significant figures. Remember, we start counting from the first significant figure, which is the first non-zero we find. And this is the first non-zero. So the next digit, despite being a 0, counts as the second significant figure. So this becomes 6.0. Now we look at the next one, which is a 7. And what does that imply? It means we have to add 1 to this. So of course, our final answer becomes 6.1. Okay, so there you go. To the nearest whole number, we have 6. To the nearest tenth, we have 6.1. To the nearest 2 decimal place, we have 6.07. And then to 2 significant figures, we have 6.1. And that's your answer. Let's look at another example. Now, in this particular example, we have to approximate 36.549 to the nearest whole number, to the nearest tenth, to 2 decimal places, and to 2 significant figures. So let's have at it. So for the first one, where we are doing to the nearest whole number, we have 36.549 to nearest whole number. Now, what does that mean? It means we have to keep every digit before the decimal point. So we have 36. Okay? Now, point. What happens to the remaining? They ought to become 0, but we don't just go on to make them 0. We first look at the next digit after at the required number of digits we have to keep. And that digit is 5. And remember, when we have 5, 6, 7, 8, or 9, what do? It means we add 1 to this. Then we round every other thing to 0. Okay? So what does that give us? We have 37.000, which is basically 37. So it means 36.549 to the nearest whole number is 37. It means this number is closer to 37 than it is to 36. Now let's approximate the same digit, the same figure rather, to the nearest tenth. So now 36.549 to nearest tenth. What does that mean? It means the digit after the decimal point, which is the 10th place value, is where we are going to keep this up to. So we're going to be having 36.5. These are the number of digits we have to keep. Now we're going to look at the next digit after it. Now that next digit is a 4, which implies that we do nothing to this, but instead round down the remaining to 0. So this becomes zeros. So we only keep these 3. So our final answer is 36.5. And it means that this 36.549 is closer to 36.5 than it is to 36.6. Okay? So now we go to the next one. We have to do it to 2 decimal places now. So 36.549 to 2 DPs. Now what does this mean? It means we're going to keep it up to 2 decimal places. So we have 36.54. These are the 2 digits, decimal places. Okay? And the next one after the 4 is a 9, which implies that we have to add 1 to this. And when we do that, we have 36.55 as the approximate value to 2 decimal places. And then finally, to 2 significant figures, we have 36.549 to 2 SF. So it means the first two digits starting from the first non-zero. Now this is the first non-zero, so we have 3, and the next digit becomes the next one, which is a 6. Okay, so now we have 36. Now the next digit that comes is a point. Now we have 5, so it means that we have to add 1 to this, and this becomes 37. So if we are approximating this to 2 significant figures, the answer is just the same as when we approximate it to the nearest whole number. They are both 37. Now here's the thing. You need to understand that sometimes you will get similar answers in some specific degrees of accuracy, but it doesn't mean that you have done it to the same degree of accuracy. They are just coincidental in those kind of cases, okay? So when you find such, it's interesting to look at, but do not forget that the step you have taken in both cases are not exactly the same. Okay, so now we know how to approximate by this. Let's look at some other question, and then you're going to try them and we compare what we get in these videos. Now you try to approximate 0.0217 to the nearest whole number, to the nearest tenth, to the 2 decimal places, and to 2 significant figures. Now don't forget that you can always get this right as long as you follow all the steps required to approximate properly. So please feel free, pause the video and try to answer this question yourself. And don't forget to compare your answer with what is gotten at the end of this video so that we can see if you know how to approximate values like this to the nearest whole number, to the nearest tenth, to 2 decimal places, and to 2 significant figures. So now pause and solve the question. If you have solved the question, this is what the answers are. Now, when you approximate 0.0217 to the nearest whole number, the whole number we have here is 0. and the next digit after is also a 0, which means we do not add anything to it. So our answer is simply 0. This is the nearest whole number of 0.0217. Now, when you approximate it to the nearest tenth, it means we're going to consider the next digit. So we have 0.0217. So we are getting up to this point. So we have 0.0. And the next digit after that is a 2. Okay? So, and this means that we leave it just as it is. So our answer is 0.0. But there's a difference. 0.0 are the same in value. But when you write your answer, you always have to leave this one as 0.0 because you have to show it to the nearest tenth. So that tenth place value has to be shown in your answer, as opposed to this one that does not need that. Okay? So the next one says to 2 decimal places, and the number is still 0.0217. Okay, so it means we're going to have 0.02, and we consider the next digit, which is 1. Okay, so since it's a 1, it means nothing happens to this. Our answer remains 0.02. Every other thing obviously becomes a 0 and becomes unimportant in our answer because we only need to show it to 2 decimal places, and this already expresses that. And then finally, let's do it to 2 significant figures. We have 0.0217. Now, the first significant figure is the first non-zero, which is a 2, followed by a 1. So we have 0.021. Okay? Now, the next digit is a 7, which means we have to round up. So we add 1 to this, and our answer becomes 0.022. Okay? So this would be the approximate value of 0.0217 to 2 significant figures. Now, if you did get the same answers as this, which is 0, 0.0, 0.02, and 0.022, it means that you have been able to approximate this number correctly. However, if you're unable to get the same answers, it shows that there is still a little bit of problems with approximation for you, and we'll be more than happy to help you get better. So all we need you to do at this point is please let us know where the problem area is, whether it is approximating by whole number, approximating by the nearest tenth, or to 2 decimal places, or to the 2 significant figures, and we'll be happy to make a video explaining that aspect to you a little differently, that is tailored to your own specific needs. We don't want to leave anyone behind, so please let us know how we can help you get better. Another question to sharpen your skills on approximating numbers. So we have approximate 0.9074 to the nearest whole number, to the nearest tenth, to 2 decimal places, and to 2 significant figures. Okay, so what do you get when you approximate this to this degree of accuracy? Once again, pause the video and try it out yourself, and let us know your answers in the comment section. Now you can try them. Alright, so if you've been able to solve it, this is what your answer should be like. In the first case, we're to approximate to the nearest whole number. So we're approximating 0.9074 to the nearest whole number. That means we're going to keep 0. And then we look at the next digit after it, which is a 9. And it falls amongst the group of digits that implies that we have to add 1 to what we are keeping. So we add 1 to this, and now we have 1. So that is 0.9074 is approximately 1 to the nearest whole number. Now the second says we, of course, approximate to the nearest tenth, so 0.9074. So the nearest tenth is this digit here, so we have 0.9. And then the next digit after that is a 0, which falls amongst the group of digits that imply that we just keep the required digits as they are and round the others down to 0. So it means our final answer is just 0.9. Every other thing here is 0. Okay, so we just keep it at 0.9 since we are only required to keep it to the nearest tenth. So this is our answer here. Don't forget, whole number we have 1. To the nearest tenth now we have 0.9. Okay, so now let's go to the next. The next one says to 2 decimal places. Now, working with 2 decimal places means that we have to look at it up to this 0. So we have 0.90. And the next digit after the 0 is a 7, which implies that we add 1 to this and then round the others to 0. So we have 0.91 to 2 decimal places. And then finally, to 2 significant figures, remember we are dealing with 0.9074. Now look at this. The first non-zero is a 9. The next digit is a 0. Now some students make this error. When they're asked to work with significant figures, they only count non-zeros. But the trick is, start with the first non-zero. Every other digit counts. So this is 1, this is 2, this is 3, this is 4 when you are talking about significant figures. So since the question says to 2 significant figures, we're going to keep 0.90. These are the 2 significant figures. So the next digit after this degree of accuracy is 7, which implies we add 1 to this, and our final answer is 0.91, which is the approximate value of 0.9074 to 2 significant figures. And this is basically how we approximate. I hope you do understand it. And if you have any question at all on the steps of approximation, please let us know in the comment section. And if you haven't subscribed, kindly click the subscribe button so that you too can join our trip of learning mathematics the easy way with Oyalearn, your flawless school tool. There are some basic operations that involves approximation. Okay, so like what we have on the board here says to round off each of the following to the nearest whole number and simplify. So round off each to the nearest whole number and simplify. So we have in the first case 81.76 minus 39.54. And then in the second case we have 9 whole number 1 over 5 plus 17 whole number 5 over 6. So in order to do this, we have to first round off each of these figures to the nearest whole number, and then we can then simplify. Okay, so let's start with the A part. Solution. Okay, so for the A part, we have 81.76. Now when we approximate this, what do we have? The whole number is what? 81. Okay, and the next digit after that is a 7, so it means plus 1, and that gives us 82. Okay, now the next one we have 39.54. Now this gives us 39, of course, plus. Now the reason why we're adding 1 is because the next digit is a 5. So, and this gives us what? That gives us 40. So now we can now simplify, since we have 82 minus 40. And this would give us 42. So the answer to this question is 42. Now to the B part. We have 9 whole number 1 over 5, which when we write this as an improper fraction, that will be 5 multiplied by 9, which gives us 45 plus 1, and that is 46 divided by 5. Now this would give us, now let's write it in decimal fractions. Okay, 5 goes in 46 9 times. Point. Now in 1, that is 0. Okay, so that will give us 9 points. Now let's do that here. Observe. Remember 46 and then 5. We have 9 here. That gave us 45, right? So 1. 5 in this, of course, is not possible. So what do we do here? It means we have a decimal point here, and then that gives us a 0. So now we have 0.2, because 2 times 5 gives us 10. So now we have 9.2. Now let's do the same thing to this. Remember, we still have to write this to whole number, and if we do that, it means we're going to be having approximately 9.0, or basically just 9 to the nearest whole number. Now we have 17 whole number 5 over 6. Okay, so what does this mean? It means we're going to be having 6 times 17. Let's do that here. Okay, 17 multiplied by 6. 6 times 7 will give us 42. Carry the 4. 6 times 1 is 6. Plus 4, we have 10. So 102 plus 5, and we have 107 divided by 6. And this will give us what? Now let's divide. Observe. 107 divided by 6. And 6 goes in 10, of course, once. And then we have a remainder of 4. 6 go in 47 just 7 times. And then 17 times 6 gives us what? 102. So remainder 5 here. So when we put a point here, that gives us a 0. And 6 goes in 50 how many times? Of course, we know that 6 times 8 would give us 48. So that means it goes 8 times. So 48, remainder 2. Add another 0 to this. 6 goes in 20. That's about 3 times. And 3 times this, that gives us 18. And then remainder 2. And it continues like that. 17.833333. So let's put that down here. 17.83 and so on. So when we approximate this, we'll have 17 plus 1. Since this is a 8, so that gives us what? 18 to the nearest whole number. Now, the question says we add them up. So that means we are having 9 plus 18. And this would give us 27. Okay? So this is how you solve problems like this. You simplify problems like this involving approximation. This particular question says to approximate to the nearest tenth and simplify. Now, the first part, we have 0.0241 multiplied by 0.055. Now, what does that give us? So we see that 0.0241 is approximately, remember, to the nearest tenth. So that's 0.0. Now, this is a 2. It means we don't get to add anything to this. So we have 0.0. And then in the case of 0.055, this is approximately, okay? So 0. Now we have to add 1 to this because the next digit is a 5. So it means 0.1. So in the end, we see that the A part gives us 0.0 multiplied by 0.1. And the answer is 0. As simple as that. Now let's do the B part. To the B part, we have 1.666. This is approximately 1.7 to the nearest tenth. And then 0.987 is approximately what? Now, questions like this can be a little bit confusing for students. So let's look at it this way so that you understand what really goes on here. So now, we know that we're doing to the nearest tenth, which means we have 0.9. The next digit is 8. It means we have to add 1 to this. And when you add it, this becomes 10. So you write the 0, carry the 1. And 1 plus 0 gives us 1. So it's actually 1.0. Okay? Not 0.10. I've seen students make that error countless times. So always remember that you have to add the 1 and follow your normal steps for addition of numbers when you're dealing with decimal fractions and you can't miss the mark. Okay, so now what we have here is 1.7 divided by 1.0. And the answer is always going to be 1.7. I hope you get it now. Here is another question. And it says to approximate to one significant figure and then simplify. So for the A part, we have 0.0241 multiplied by 0.00571. And then for the B part, we have 750 naira divided by 39. Okay, so let's find what the solution to this problem will be. So we start with the A part. So we have to first write each of them to one significant figure. So 0.0241 approximately to one significant figure would be 0.02. Okay, it becomes 0.02 because the first significant figure is the first non-zero, which is 2 here. And the next digit after it is a 4, which means we do not add anything to it. Instead, we round every other thing to 0. And that's how we get the 0.02. And in the other case here, we have 0.00571. This becomes approximately, remember the first non-zero is the first significant figure, and that's 5 here. So we have 0.00. Now, instead of writing down the 5, we consider the next digit, which is a 7, which implies we have to add 1 to the 5, and it becomes 6. So this is the value approximates to one significant figure. Now, all we need to do is multiply these two. So I'll write them so that they have the same number of decimal places. So since this is 3 decimal place, I'll write this one to 3 decimal place as 0.020. Now multiply that by 0.006. Let's find out. So 6 times 0, that's 0. 6 times 2, that's 12. So 2, carry the 1. 6 times 0, that's 0 plus 1, and then we have 1. And then 6 times 0, and that's 0. So we continue for the rest, and then you find that since they are all zeros, we have 0, 0, 0, 0, 0, 0, 0, 0. That's for these two. Now to the third one, we're having 0, 0, 0, 0. And by the time you add all of this up, what are we going to get? This is 0, this is 2, this is 1, then 0, 0, 0, and 0. Now, where does the decimal point lie? It is right here. Okay, so since we have this, it means our answer is 0.000120, which is basically 0.00012. Okay, so now we have our answer to multiplying these two. Remember, we first approximated them to one significant figure before multiplying. Now let's do the same thing to the B part, but this time remember we are dividing. So here 750 naira becomes approximately, remember, to one significant figure, so we deal with this 7, and then the next is a 5, which means we add 1, so it becomes 8, so 800, writing the others as 0. And then we have 39, which is approximately, of course, we add 1 to 3, which makes it 4, and then the other becomes 0, so we have 40. So now we have to do 800 naira divided by 40. Now, in 80, that is 2. 2 times 40 is 80. Okay, that's 0. And 14 0 is 0. So now we see that our answer is basically, it shows that 800 naira divided by 40 would give us 20. And that's the solution to these problems. This question says to find the exact and approximate value of 199 multiplied by 21. Now you see questions like this, when you see something like this, it's quite difficult to want to get the answer straight when you try to multiply 199 by 21. Okay, so you have to always show your workings as you try to solve this kind of a problem. However, when you use the approximate values of these different figures, it's quite easier to multiply. So let's see what happens there. This helps us to sort of show why approximation is a way of making calculation a lot easier. So solution. Let's start with the real value. For the real value, we have to go 199 multiplied by 21. Now, 1 multiplied by 9 gives us a 9. 1 multiplied by 9, another 9. 1 multiplied by 1, and that gives us 1. Now, 2 multiplied by 9, remember we have to write this under the place value. 2 multiplied by 9 gives us 18, so 8, carry the 1. 2 multiplied by 9 is 18 plus 1, and that gives us 19, so 9, carry the 1. And 2 multiplied by 1 is 2 plus 1, and then we have 3. So this empty space, we can fill it with 0, and then go on to add everything here. So we have 9 here. We have, this is 17, so 7, carry the 1. Now this is 11, so 1, carry the 1. And then we have 4,179 as the real value of 199 multiplied by 21. But if we're working with the approximate value, note we have 199, which is approximately 200. And then we have 21, which is approximately 20. So now we have 200 multiplied by 20. So what do we do here? It's very simple. Just say 2 multiplied by 2, and that gives you 4, right? Now you write down all the zeros we have. So 0, 0, and 0. So our answer here is 4,000. Now compare 4,000 and 4,179. You see, they are not far off from each other. The difference is 179. 9. So when you have questions like this, it's quite easier to work with the approximate value than it is to work with the exact value. Mind you, the answers are not the same. It just shows that they are closer to each other but not exact. And that is the main idea behind approximation. So now that we know how to approximate and can do some basic operations involving approximation, let us look at some examples of approximation in daily life, in our everyday life. So we'll be looking at some questions that borders around our everyday life and how approximation can help us solve those problems with ease. Now to everyday activities involving approximation. We have a question that is one of those things that you will come in contact with in your day-to-day activities. This says a crate of soft drinks. You're familiar with soft drinks, right? And now when a crate contains 24 bottles and the capacity of a bottle is 35 centiliter. Now what centiliter means is that 100 of these make up 1 liter. 100 centiliter makes 1 liter. Okay, so each bottle is 35 centiliters. That's 0.35 of a liter. Okay, estimate the quantity of drinks in 2 crates in liters. So we first have to find the quantity of drinks in 2 crates and then estimate it in liters and work it out in liters. That is, what is the final answer in liters? Convert it to liters from centiliters. Now, to work with a question like this, all you need to do is multiply 24, which is the number of bottles, by the capacity of each bottle, which is 35 centiliters. And you agree with me that multiplying 35 and 24 is slightly difficult compared to multiplying their approximate value in one significant figure. This will be 20, while this will be 40. 20 times 40 is quite easier to do. So let's do that. Since we are to estimate, don't forget that estimate means what? An educated guess. So approximation is all about guessing from an educated standpoint. So let's see what that will give us. Okay, so now we're going to be having normally 24 bottles multiplied by 35 centiliters. Now this is basically approximately 20 multiplied by 40, and this gives us an approximate value of, now when we work with this, of course 2 times 4, that's 8, so 0 and 0, so 800 cl. Now this is going to give us 800 divided by 100 times 1 liter. Okay, and this will give us 8 liters. So it contains 8 liters. Now, if we were to do this the normal way without approximation, what we would have been doing is saying 24 multiplied by 35, and that will give us 840. And this is in CL, so 840 CL divided by 100 CL multiplied by 1 liter would give us what? 8.4 liters. And you see that 8.4 liter and 8 liters are very close. And since the answer said we should leave our answer in liters, agreeing that 8 liters is very close to what we should get normally. So it's a very good educated guess, or like the question says, a very good estimate of what the answer is. Once again, close to the answer but not exact. But this is how you work with estimation or approximation in day-to-day activities, especially with word problems like this. Let's take other examples. Here's another example of a word problem involving estimation or approximation. Now, at this point, if you still haven't subscribed to the channel, kindly take a moment of your time, click the subscribe button. That's one way you continue to encourage us to continue to make these helpful videos right here on Oyalearn, your flawless school too. And don't forget that you can help out your friend to get access to this video by sharing these videos to them as well. So they too can help the academic journey become more smoother by checking out our videos right here on the channel. And we welcome all your questions. If you have any question at all on what we're doing, or perhaps there's a particular topic you need our help with, all you need to do is put a question across to us via the comment section, and we promise to attend to all of your comments. So just keep them coming. You will definitely get a response to all of your comments. Thank you all so much. Now this question we're about to solve says the area of a garden of flowers is 22 centimeters squared. Okay? Estimate the total area of 27 gardens of flower. Remember, one garden has an area of 22 centimeters squared. Now we want to find the area of 27 of such garden. Here's the solution. We're supposed to have 27 multiplied by the area of each garden, which is 22 centimeters squared. So since we are to estimate it, we can then work all of these to one significant figure, that is find an approximate value for 27. So this is approximately, remember 27 is approximately 30 and 22 is approximately 20. So we have 30 multiplied by 20 centimeters squared. And this is way easier to work with. All we need to do is, it says 3 times 2, that gives us 6, and then 0, 0. So we have 600 centimeters squared as the approximate area of 27 garden when one of them is 22 centimeters squared. So here's the solution to the problem. Ada bought 2.5 kilograms of chicken, 6.25 kilograms of fish, and 1.75 kilograms of crayfish. Estimate the quantity of items bought altogether to the nearest whole. It's a very interesting math problem. But personally, I think someone should tell me where Ada is. I'm interested in these items more than calculating them, but that's just to digress, okay? What does the question really say we should do here? Okay, what we need to do is first estimate each of them to the nearest whole and then add them all together. And so doing, we'll get the total quantity of what she has bought to the nearest whole number. So let's see what that will give us. First, we see that she bought 2.5 kilograms of chicken. Now, 2.5 kilograms is approximately 3 kilograms. And then she bought 6.25 kilograms of fish, and that is approximately 6 kilograms to the nearest whole number. And then finally 1.75 kilograms of crayfish, and this is approximately what? 2 kilograms. Now this is what we need to add up. If you go on to add all of this, you'll find that altogether it is 11 kilograms of items to the closest whole number. But if we have added this all together, what would we have gotten? If we added this, you would get 10.5 kilograms. You see that they are very close, right? But the answer required for this question is 11 kilograms. I hope you get it. If you have any question on this, please put them in the comment section. Here is another question on everyday activities involving approximations. Now, it's a quite lengthy question, but it's very simple to solve. So let me give you some time, pause the video, and try to solve the question. The question is right on the board, okay? So read it off and then try to solve it. So, go! Alright, to those of you who have solved it, let's see if you did it rightly. Okay, the question itself says, a bag of rice contains 64 measures and each measure contains 5 cups of rice. Round off the number of measures of rice in a bag first, then estimate the number of cups of rice in one bag. Find the difference between the approximate and exact number of cups of rice in one bag. So it's a 2-in-1 question, so let's solve it. The first thing we have to do is to round off the number of measures in one bag of rice. So one bag of rice consists of 64 measures, okay, which is approximately 60. Okay, so that means that estimate cups of rice in one bag therefore becomes 60 multiplied by 5, and this is going to give us 300 cups of rice. Okay, now the exact value. exact cups of rice, that is going to be the number of measures, which is 64, multiplied by 5, and this will give us what? Now, 64 multiplied by 5 will give us 320 cups. Okay? So the difference is 320 cups minus 300 cups, and that gives us 20 cups. And that's the solution to this problem. If you did get the same answer as this, let us know by saying in the comment section, I got the question correctly. Now, to those who are unable to solve it, please do not fret, do not be dismayed at all, as the first time is not always what is required for you to get the questions right. Sometimes it takes practice. Sometimes you don't just get it from the first go. And that is why we are always here to ensure that we help you get there. And we are with you every step of the way. So all you need to do now is let us know in the comment section what part of these calculations seems to be a problem for you, and we'll be more than happy to explain it to you in a way that you are going to understand. Remember, this would be us answering or helping you based on your own specified problem area. So that would be us giving you a response that is tailored specifically to your own needs. So please let us know. Don't be shy. Just drop that in the comment section and we are here for you. Please don't forget to subscribe to the channel as well. That will be a way to encourage us to continue to make these helpful videos that we are always making right here on Oyalearn, your flawless school tool. And please help others by sharing the video. Ensure that you engage with the videos by liking and dropping a comment, and help us to continue to help students like you. Thank you all so much for being part of the video so far. We've been able to look at approximation. I hope you haven't forgotten the meaning of approximation and the steps required to approximate a figure to a specific degree of accuracy. And if you do have any question at all on what we have done so far, please drop them in the comment section and we'll attend to all of your comments. Thank you for being part of the video so far. I will be seeing you in the next video. Bye for now.